is starting to mesh together. Things that seem to be totally opposite and different are going to actually come together with thanks to complex numbers. So if you go to 2, we did 1 already, didn't we? We finished that one together. So in this one, what I would do is do a separation of variables. Keep the constant I with the d theta, and then move the dy so it's in the numerator. Remember how we did that? dy and d theta are in the numerator. Then integrate both sides, and you're going to get I theta equal to the natural log of y plus c. Now to find c, we're going to have theta equal to 0 and y equal to 1. What's the natural log of 1? Yep, and 0 times anything is 0, so c is equal to 0. So if c is equal to 0, I theta is equal to the natural log, or log base e, of y. Solve for this by changing into exponent form. This is going to be e to the what? Good. Is equal to y. That's what you were trying to prove. So if y was cosine theta I sine theta, then we say that this is equal to e to the I theta. Now, e to the negative I theta is just going to be the cosine of negative theta plus I times the sine of negative theta. Would you fix that if you didn't have that? You're just putting a negative theta in for I. What I would do is think of it this way, is the same as negative I theta. Do you agree with that? So then the cosine, hold your arms out like this. Cosine of theta is up here, the negative theta is here. What do you notice about cosine theta and cosine of negative theta? Same. Yeah. So we can write this as the cosine of theta. And then how about the sines? What happens? This sign goes up for theta, goes down for negative theta. The signs are opposite, so it would be negative I sine theta. How many got that? You remember those functions? One more time. Here's your theta. Here's negative theta. If you look at this from a x standpoint, those x's are the same. Cosine negative theta is the same as cosine theta. But if you look at the y's, they're opposites, and that's why the I sine theta is the opposite of I sine negative theta. All right, next, they would like you to figure out what e to the I theta plus e to the negative I theta is. Well, all you do is just plug these in. E to the I theta is this, e to the negative I theta is that, and you probably guessed it, things are going to cancel out. Cosine theta plus I sine theta, and then this one's going to be plus cosine theta minus I sine theta. What happens to the I sine thetas? Goodbye. They're gone. So now we have 2 cosine theta over 2, which is cosine theta. Wait a minute, wait a minute. This is what cosine is? Huh? Cosine is, you probably saw that at the internet somewhere, or maybe even Wolfram Alpha when you're defining cosine. They'll define it this way, as e to the I theta plus e to the negative I theta over 2. Isn't that cool? I think that's pretty cool. Now this one is the same thing, cosine theta plus I sine theta, but they're just going to subtract cosine theta minus a negative I sine theta. So when you divide by 2i, this time the cosines are going to cancel, and you're going to be left with 2i sine theta over 2i. And what's left now? Sine theta. So this is what sine theta is equal to. Yeah, very cool. Now the next one, this is what I led you into before. I told you that e to the x was 1 plus x squared over 2 factorial. Let's go all the way out to 4 factorial, 5 factorial. I'm going to go all the way out to 6. Oh, let's go 7. X to the 7 over 7 factorial. It does keep going, but we're going to stop there. For sine of x is x minus x cubed over 3 factorial plus x to the 5 over 5 factorial minus x to the 7th over 7 factorial. Cosine is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial. That's kind of boring, don't you think? A little boring. But what happens when I do e to the I theta? What am I replacing x with? What's x being replaced with? I theta. So wherever you see an x, replace it with an I theta. Let's do it. 1 plus I theta plus I squared theta squared over 2 factorial plus I cubed theta cubed over 3 factorial plus I to the 4th theta to the 4th over 4 factorial. And I'm going to just keep going 2 more times. Theta to the 6th, 6 factorial, I to the 7th, theta to the 7th over 7 factorial. Whew! Now, what's I to the 2nd equal to? -1. What's I to the 4th? Yeah, this is going to be +1. I to the 6th is -1. In between, you have I, then you're going to have -I, and then you're going to have I, and then we're going to have -I. And if I group these that don't have i's, the ones that don't have i's will be 1 plus, -1 minus theta squared over 2 factorial plus theta to the 4th over 4 factorial, and I can do one more, minus theta to the 6th over 6 factorial. That's one thing. And then I'm going to do another thing. That's the ones that have i's. So I'm going to take out an I. Sounds horrible, violent. You take out an I and you have theta. And then you're going to take out an I here, and you're going to get negative theta cubed over 3 factorial. Then you're going to take another I out. You're going to get plus theta to the 5th over 5 factorial, even a negative theta to the 7th over 7 factorial. Now, tell me, what is this whole thing equal to? Cosine theta, right? That. And what's this equal to? Sine theta. So, okay, you ready? E to the I theta turns into cosine theta plus I sine theta, which you proved a different way before using that. You proved before using the separation of variables. And then you just go ahead and put the pi in for theta, and pi putting in here. What's the cosine of pi? What's the cosine of pi on the unit circle? Unit circle, what's the cosine of that? -1, right. And what's the sine of that going to be? 0. So e to the I pi is -1 plus 0. It's the greatest, most elegant math formula ever discovered. It includes exponent, trigonometric, complex, and integers. Question?
Where does the I, how do you just ignore the I when you're...
It's 0 times I.
Okay, that's
Yeah, isn't that crazy? So then on the last page, what you're going to do is you're going to multiply two complex numbers with an R1 and an R2 in front. And I'm going to let you think about this. We'll play around with this a little bit more, but what you're going to do, well, let's do this. You're going to multiply these two. So you get R1, R2, cosine X, cosine Y. Now I'm going to multiply these two together. Plus I, which do I want to do first? Yeah, sine Y, cosine X. And then I'm going to multiply these two. Plus, oh, there was an R1, R2 in here. R1, R2. This one has an R1, R2, and it's going to be sine X, cosine Y, and then last but not least, in red, I'm going to have R1, R2, and what is that? Sine X, sine Y? Stare at that. Which of those colors do you want to put together? I like the green and red. Let's do it. Put the green and the red together. And that is plus. Good. And that's going to leave, I'm trying to see which ones I want to put first. I'm going to put this one first. And this one last. Forgot the little R1, R2 here. There's an I here. So what is, factor out an R1, R2. What's cosine, cosine, sine, sine? What is that? Cocosisi. It's the cosine of X minus Y. Good. And then I have an I for these two. There's an I here and an I here. Plus I. And what is sine X cosine Y plus sine Y cosine X? Actually, it'd be cosine X sine Y. What's that? Sine X cosine Y, cosine X sine Y. What's that? Sine of X minus Y. So what this is, did I do something wrong? I think that's right. This can be simplified to something called cis form of X minus Y. Something is bugging me about this. I'm not quite sure what. Here, cosine X, cosine Y. That's cosine X. Yeah, I think that's right. I thought it was plus, but all right. Little fix here. You're going to change this to pluses because thanks to Bo, we caught this error here. When you multiply I times I, you get I squared. What's I squared equal to? -1. So this becomes a minus. So that makes this x plus y, and then this will be sine x plus y.